Hi, my name is Ang Wei Lo, and I'm a fellow in the System Design and Management program at MIT. I'll be talking about a project that I've been working on, which is called tiengXie. tiengXie is the Chinese version of spelling, and the aim is to build a web interface using HTML and JavaScript to help with learning to write Chinese characters. In the Singapore education system, where I'm from, tiengXie plays a big role in how Chinese is taught at the primary school level. Students are given a list of words to memorize and practice writing on, and frequent tests are administered to ensure that they have learned the words well. As these tests require preparation beforehand in order to do well, parents often help their children learn the words at home. However, as more families become dual income and parents have less time to help their children with schoolwork, it would be helpful to automate this learning process. Add on the fact that parents themselves might not be proficient in Chinese, and the value of such a project becomes greater. The web interface consists of two components, a writing component and a game component. The writing component provides the phonetic script of the Chinese character and tests the student's writing. This is sent to a server hosting a convolutional neural network that a friend of mine developed in order to recognize and classify the written character. The server then provides a response on whether the word was written correctly or not. This is linked to a snakes and ladders game, where each time the student writes a character correctly, they are allowed to roll the dice and move the number of steps rolled. Each time the student gets a character wrong, they lose a turn. The aim is to get to the final square in as few turns as possible. Both components have been refined over the past few weeks into the final product that will be demonstrated later. The final product consists of the following files: tiengxie.html, which sets the layout and loads the required scripts for the web interface; words.js, which contains the word database obtained from the Ministry of Education of Singapore website and functions to generate random words; drawingboard.js, which is an open source script for integrating a drawing canvas in HTML created by Emmanuel Pelletier; game.js, which runs the Snakes and Ladders game. This was adapted from Manas Bhadraj's basic game and modified to include the specific requirements for my project; run.js, which has the code to process the written character, communicate with the server, and link the writing and game components together. There are several steps that go into processing the written character once it is written and submitted by the student. So I will go into more detail as this was the most complicated part of the project. First, the drawing canvas is saved as an image. Its pixel data is then accessed to determine where the writing is and where the white space is. The width and height of the written character are then determined, and the tightest square possible is fit around it such that it is centered in the square. Next, the cropped image is scaled down to 70 by 70 pixels and its pixel data is accessed to convert it into black and white. A binary array of the image is also generated where zeros correspond to white space and ones correspond to the writing. The binary array is converted to a string and is now in the proper format. It is sent to the server hosting the algorithm using AJAX. The server responds with its classification of the written character and an associated probability. If the classification matches the correct character, the student is allowed to roll the dice to play the game. If the classification does not match but the probability is below 50%, the student is given a chance to write the character and submit again without penalty. However, if the probability is 50% or higher, the student is informed that they were wrong and the correct character is displayed. A new random word is then generated and the process repeats until the student wins the game or exhausts the entire word list. I will now do a demonstration of the web interface. This is what the web interface looks like. There are some instructions at the top of the page. When the start button is clicked, the hanyu-pinyin or phonetic script of a random Chinese character is generated, together with its English meaning. The user can then write the character in the canvas. They can use the clear button if they make a mistake. Once the submit button is clicked, the image is processed and sent to the server, and a corresponding response is received. In this case, the written character matches the server's response, so the roll dice button appears and the user can play the game. Once rolled, the button disappears. As you can see, the submitted answer and correct answer are also displayed below. A new random character is then generated. Now let's try submitting the wrong answer. If the answer is wrong, the roll dice button does not appear. But if the classification probability is less than 50%, the user can try again without penalty, like in this case. If we look at the developer tools, you can see the response from the server. And in this case, the probability is less than 50%, and that's why it asked it to submit again. Now that it's correct, the roll dice button appears, and you can click to roll. Now let's try getting a wrong answer again. So if you get a wrong answer, and the classification probability is above 50%, the server tells you that it is wrong, and it doesn't give you a chance to retry it. The correct character will be shown over here, and you'll move on to the next character. So the user continues until they reach the final square. At which point a prompt will be given, and it tells them how many turns they took to finish the game. I hope you enjoyed the demonstration. Further details on how everything works can be found in the code as comments. In the first version of the web interface, the accuracy of the classification was not very good. This was because of the large variability in how the character was written on the drawing canvas. It could be skewed to one side or take up only a small portion of the canvas. This risk was mitigated by adding in the additional process of fitting the title square around the image and centering it prior to sending it to the server. As with all machine learning algorithms, the accuracy can still be improved. There are some characters that look very similar to each other, often differing only by a stroke or two. Hence, the algorithm might not always get the correct classification. This will be further complicated once more words are added in the future. Hence, we will continue to train and refine the algorithm. The current web interface is completely functional as it is, but more improvements can definitely be made. One is to add more animation and interactivity to the Snakes and Ladders game to make it more interesting. Another would be to build in a multiplayer mode so that students can learn together and have some friendly competition. Finally, making the interface mobile and touch compatible would allow it to be accessed on the go. Education is evolving and starting to embrace more technology. This project is a quick peek into the potential application of machine learning to help with learning how to write Chinese characters. Hopefully, as it is developed further, its application can be extended to other areas as well. Thank you for watching.
Created using Powtoon.